All right, welcome to the third video about distance between 2 points. So we're just going to be doing a Khan Academy activity for this third piece. Just so we know that of the three pieces, I guess this would be the most practical one. This is going to be most similar to what your quiz is going to be like for this week. So of the three, if you're not understanding them, spend your time on this third piece reworking this. Okay, the first two pieces kind of help to build the idea of what we're going to be doing in this video. But if you're going to really spend your time digging in and practicing over and over again, this is where I would spend your time. Okay, so on Khan Academy, we have two different kind of problem types. We have these ones where they give you a graph, and they give you these problems where there isn't a graph. They just give you 2 points. Just so you know, on the quiz for this week, we won't be assessing you, and actually for this whole unit, we're not going to assess you on finding the distance between 2 points if there's not a graph provided. But you will need to know this for high school, so spend some time practicing it. But I don't want you stressing out if you're struggling without the graphs on finding answers, because again, we're not going to be assessing you on it. As long as you're understanding the ones where there is a graph, that'll be good for this year. So let's look and see how to do this. So when we're looking for the distance, what we're talking about is that straight line distance. If you go from one point straight to the other point, right? That distance there. And remember, we can't just count across here because it doesn't follow along these lines. So what we have to do to find this distance is we have to put in a triangle and then use the Pythagorean theorem. Now, if you look at this, and hopefully some of us are starting to with some of the other activities, especially the GeoBoard activity, realize that when we're putting in these triangles like this, it's very similar to when we were doing the slope triangles earlier in the year. It's the same kind of process. We're putting in a triangle, so we're going straight side to side and then straight up and down between 2 points. And just like when we did the slope triangle, it doesn't matter if we go below the 2 points or below this blue line, or if we would have went above. It all works out the same. The difference between what we're doing here and the slope triangle was on the slope triangles, we could use any points on the line. It didn't matter what points we used, but with this, we have to use the given points, right? And that makes sense because we're looking for the distance between these two given points. So it wouldn't make sense for us to use other points because that won't give us the distance between those 2 points, okay? But in terms of drawing in these triangles, it's very similar to drawing in your slope triangle. After we have the triangle constructed, notice what we're looking for is the hypotenuse. That's the longest side of this right triangle, right? Because this is the right angle right here. And so using the Pythagorean theorem, we know, since we're looking for the biggest side or the hypotenuse, that what we're going to be doing is adding the two little squares to get the area of the big square. Okay, so let's draw in those squares. So we're going to have a square here, and then another little square here. And remember, we're going to add the areas of these two together to get this third square that I haven't built yet. So to find the area here, since this is a square, we know this side length and this side length are going to be equal because it's a square. And so once I find these side lengths, I just multiply that number together, multiply by itself, or I square it, right? And that'll give me the area here. And to find the side length, since it's on the graph, I can just count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 across, right? So to find the area here, I just take 9 squared, which is 9 times 9, which equals 81. Try my best to draw on my screen here. Okay. And for this little square, we're going to do the same thing. I'm just going to count the side length. So it's 1, 2. So obviously this one's 2 as well. So 2 times 2 is 4. So the area of this littler square is 4. Okay. So these are the two numbers I'm interested in, the 81 and the 4. And remember, we talked about that this big square that comes off of here, and that wouldn't really fit on the screen, so we'll just draw it like that. This big square up here would be this 81 plus this 4. So 81 plus 4 is 85. So the big square up here is 85. But remember, we're not interested in the area of this big square. We're looking for the side length of the big square, right? And hopefully we've done enough practice to know that if I'm looking for the side length of that square, I just take the area of the square and I take the square root of it. Right? You take the square root of the area, gives you the side length of the square, and that'll give me my answer. Now we have to talk about what the answers look like. In Khan Academy, if they're not perfect squares, they're going to leave them as square roots. So you can see we found the answers right here, right? Square root of 85. On your quiz, however, we're going to have you actually find the number that's about the square root of 85. Okay, and so how you do that is if you look over in this little side screen, I'm going to put up my answer chart that you guys should have constructed. Make that a little bigger, right? We would just find 85 in the chart, so it's a little bigger than 81, so I know my answer is a little bit bigger than 9. So we would put 9 point something, right? And at this point, it doesn't matter what your decimal is, as long as you recognize it's a 9 point something, right? So it's a little bigger than 9. It's closer to the 81 than the 100. So I would pick a decimal closer to 9 than to 10. So I'd pick like a 9.2 or a 9.3 as my answer there. Okay. So hopefully you guys practice that enough. Also at this point, if you guys haven't started to, you can also use calculators to get those answers. Okay. And you just type it in. The square roots are where they're located is different on every calculator. So, if you've made one of these charts, it's almost faster just to look on your chart because again, we're just going to be estimating the solutions. Right? We're never going to have you actually give the exact answer. Okay. All right. So that's that one. I wanted to look at. Right. So there was the answer. Square root 85. I wanted to look at the one where there isn't a graph given. These ones are actually very similar to these. Again, if we think about this in terms of those slope triangles, like when we were talking about earlier in the year, when we looked at finding slopes earlier in the year without a graph as well. And what we did for that is we made tables, XY tables. We can do the same thing for this. Now I'm going to do it over here in this box because this is writing on the screen is getting too cumbersome. Okay, so all we're going to do is make an XY table. And if we look and think about what's happening here, the sides of this triangle are how far it's changing in the X and how far it's changing in the Y, right? So along the X here, from -2 over here to 7, where these 2 points were, from -2 to 7, that's your change of 9, right? Because that's 2 to the 0 and then another 7, so 2 plus 7 is 9, right? And the change here is from 7 up to 9. So that's a change of 2, and that's where the side change of 2 is. So we're doing the same thing, but we're just doing it without actually drawing the picture. We're just finding those changes in our table. So if I come over to the other point, and then I'm going to make this a little bigger so we can see it a little better. All right. All I'm doing is taking those points and putting them into an XY table, right? So that first point, it's -9 in the X and -6 in the Y. The second point is -2 in the X, -2 in the Y. And then to find the sides of the triangle, I'm just saying how big of it is a change. Now, since I'm looking, right, so here's my triangle. Since I'm looking at the change from here to here, I don't really have to care if it's going up or down here. When we were talking about slope, it mattered. But when we're talking about side lengths of a triangle, I don't care about positive or negative. So I'm just taking the absolute value right? Or in other words, not worrying about positive or negative. I'm just saying, what is the change from -2 to -6? Those are 4 apart. It doesn't matter up or down. It's just a change of 4. And then the change here from -9 to -2, again, it doesn't matter up or down. We're just saying what's the difference between these two is 7. So on this triangle, one of the side lengths would be 4 and the other one would be 7. Okay, see if we can zoom in on that a little bit since I'm writing so small. Okay, and then from here, all we're doing is building our triangle and doing our Pythagorean theorem. So I'm putting a square here. 7 times 7 is 49. Building a square here. 4 times 4. The area right there is going to be 16. Define the area of this big square. Right, I take these two numbers and I add them together. So 9 plus 6 is 5. Carry the 1. Right, so that's 2. And 2 plus 4 is 6. So I get 65. And then remember to get the actual length, the side length of the square. You take the square root. So the side length of that thing is the square root of 65. And many of us already realize that is not a perfect square root, which means in Khan Academy, I'm just going to find that answer in the list. And if I come looking over on the right here, you can see it's letter C. Okay. Just remember on the quiz this week, you're going to have to actually find the number. So just to look at that real quick, the square root of 65, it's a little bit bigger than 8. And it's literally just one number bigger than 64. So it's going to be it's going to be like 8.1, right? It's just a little bigger than 8, so 8.1 is what I would write. Again, if you have any questions on any of this, please send me an email. You can come to one of the question answer times that I sent you an email about. But make sure you're getting your questions answered.